Okay, this is not a very time-consuming assignment. It's going to seem a little bit pointless, but you have to identify the domain and range of each relation, determine whether the relation is a function. Okay, well, these are xy coordinates. Okay, so in this function, when x is 3, y is 7. When x is 3, y is 8. Now, yeah, x is 3, y is 4, x is 3, y is 1. Okay, you're going to write domain and range. This is really simple. The domain are simply all of your x values. The range is all of your y values. So for the domain, I have 3, 3, 3, 3, 3. For the range, I have 7, 8, negative 2, 4, 1. Now, here's whether you tell whether it's a function. A function, to have a function, no domain value, I'm just going to put a number sign, no domain number can repeat itself. It doesn't matter what the range is, but the domain, do you have any repeated numbers in the, yeah, they're repeats. You have 3, all 3's all the way across the board. So you write non-function. Now, if none of these numbers here repeated themselves, then I would have a function, but they repeat themselves. Okay, next one, domain, range. So xy, 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 xy. Okay. So on the domain, you have 6, 5, 1, 7. On the range, negative 7, negative 8, 4, and 5. That's a 6 there. 6, 5, 4, 7. Now, look at your domain. Do any of the domain values repeat? No, they are all different. 6, 5, 1, 7 are all different, so that is a function. Okay, next one. Domain, range. So in this function, if x is 0.04, y is 2. If x is 0.2, y is 1. If x is 1, y is 5. If x is 5, y is 25. So 0.04, 0.2, 1, and 5. Then 2, 1, 5, 25. Now, do any of the domain values repeat? No, they're all different, so that's a function. Okay, domain, range. xy, 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 xy. So 4, 1, 0, 1, 4. Okay, range, you have 2, 1, 0, negative 1, negative 2. Now we have all the domain numbers, we have repeats, 4, 4, 1, 1. If you have any repeats at all in the domain, it's a non-function. Okay, so that should be pretty easy. Okay, now this next part's not hard either. Write a function rule that represents each situation. That means basically write an equation. So you're going to make your line. The P variable, the price P of a pizza is $6.95 plus 95 cents for each topping, T, on the pizza. So this is a variable we put up here. So it starts at $6.95, that's your beginning. And then 95 cents, but that needs to be multiplied by T because it's for every topping, okay? And that's your answer. But write it into an equation, 6.95 plus 0.95 times T equals P. Okay, the load in pounds of a wheelbarrow is its own weight of 42 pounds plus each 4-pound brick B that it carries. Okay, so equals L. So you have 42 to begin with, but then from there you got to add 4 pounds, but it's every brick, so plus 4 times B. I wrote something I should have. So 42 plus 4 times B equals L. Okay, the almond extract A remaining in ounce bottle decreases by that should say ounce, I misspelled it, by 1/6 of an ounce for each batch of waffle cookies made. So equals A. So we start at 8. But when you see that word decreasing, when you add, okay, that's going to be a negative 1/6. So negative 1/6 times B. So you got to be watching for that decrease. So it's 8 plus negative 1/6 times B equals A. Okay, a burst pipe has 37 inches of water. W decreases at a rate of 1.5 inches per hour. So W is my dependent variable. 37. And decreasing means it needs to be negative 1.5 times H. Okay, so 37 plus negative 1.5 times H equals W. That's how you write a function rule, same way you write an equation. Now for the last part, it says use a vertical line test to determine if you have a function. Now, we already did was it a function or not when we saw a bunch of coordinate points, okay? Like x is 3, y is 7, 3, 8. But how do you do that from a graph, okay? This is the x, this is the y, okay? And this is easy to do. To determine if any of the x, the domain points, repeat themselves with a bunch of discrete points, you just make a bunch of vertical lines. So when I draw a vertical line through there, I just went through one point, okay? When I draw a vertical line through here, it goes through 2 points, so that's a repeat, okay? See these repeats right here? They're both on the same place on the x line, okay? So as soon as I go through 2 points, I know it's a non-function. I don't need to keep going because that means repeated x's. It's the same concept of what you're doing here, just now the xy relationship is into a graph. Now those are discrete points. What do we do on a graph that's continuous? Well, a continuous graph's actually quicker. You just draw one vertical line and see this thing I have on the graph here. It's kind of a sideways U. That vertical line I just made, how many times did it cross the U? Once, twice, so that's a repeat, so that is a non-function. Okay, then here's another continuous one, okay? Again, it's continuous, it's not just a bunch of points, you don't need to make line, tear, so just one line will do. And it just crosses the U at one point, okay? So there's no repeats, it's a function. So if it crosses it twice, okay, that's a non-function because that's a repeat. If it crosses it just once, that's a function. Okay, and then here we just have a line. So just make it's continuous, okay? Just crossed the line once. This line here, the one in the black marker, crossed it once. That gives us a function. Okay, and then the assignment, function or not, function rule, and then remember discrete points, 1, 1, 1, 1, 1, 1, that would be a function, because when I drew my vertical lines through each point, I only go through one of them at a time. So when I go through 2 of them, it's a non-function. And in the continuous graphs, you just put a line through it.